I like to start with number 9. So y equals natural log x over x to the 5th. We're asked to differentiate. When we're asked to differentiate, if it's nothing else specified, it means we have to find y prime. And remember, we have several notations. This is something called Leibniz notation. It doesn't matter. You can use this or this. However, this notation is extremely useful later on in chapter 3. I'm going to talk a little bit more about this. Okay, but they mean the same thing. So here, one option would be to use what rule? What rule will you apply here?
Quotient rule?
Yes. However, let me just show you a different option. But you're correct. Absolutely. Was it George? Yes, George, right? Yes, absolutely. It's a quotient. But here's another option. X to negative 5 times natural log x, which is exactly the same function, but this time I use the product rule. It's the same. Let's see if this is easier. It doesn't matter. The answer has to be the same. So y prime, the first function prime, negative 5x to negative 6, times natural log x, and plus x to negative 5 times 1 over x. Good. I continue. Negative 5 natural log x over x to the 6th plus 1 over x to the 6th. And it's done. Negative 5 natural log x plus 1. Let's stop for a moment and look at this again. I brought down the power, and I subtracted 1 from the power, and I multiplied by the second function. Plus, I copied the first function and differentiated the second one. I used the product rule. Please remember the product rule. I saw it in your papers. The product rule is not f prime g prime. Please do not make this error. The product rule is first, second. First function prime times the second plus the first function times the second function prime. So I brought down this to the denominator because it has a negative power. So negative 5 natural log over x to the 6th. I brought down this because it's a negative power, but 1 over x times 1 over x to the 5th is 1 over x to the 6th. Luckily, they both have the same denominator. All I have to do is just copy. I could have not, I'm going to erase this. I could have not done this if I had here, let's say, plus 3 or 3x or whatever. But I was able to, because the denominator, to change it from a ratio to a product, because the denominator was one term. If it's not one term, I cannot do this. Now you can say, why did you change it into a product? Because most of the time, the product will be easier to manipulate or simplify. Let's look at how it looks with the quotient rule. I just wanted to see an alternative. Both are correct. So if we use the quotient rule, then we have the top function prime 1 over x times x to the 5th minus the top times the denominator prime, which is 5x to the 4th, over x to the 10th. So this is slightly more difficult because you have to factor, you have to simplify, and so on and so forth. Not much more difficult than the previous one. So here, when I simplify, I have x to the 4th minus natural log x times 5x to the 4th. Now, I have no choice. I have to factor out x to the 4th and simplify with the denominator. So 1 minus 5 natural log x over x to the 10th. And now I have to simplify, and I get back what I obtained with the product rule. So I'm saying that sometimes the quotient may be a little bit more, may require a little bit more work. It doesn't matter, the answer is the same. But see, this was a little bit easier to handle than this whole thing. Somewhat. Not a big deal. Any questions on this problem? Please ask anything. Okay. You can choose the next one if you want, or yes, for example, something like 13. So we look at the quotient, basically a product. We did both product and quotient. Let's also look at something like this. So I don't know if you want to choose, or I'll continue choosing. So y equals natural log 3x squared plus 2x minus 1. This looks fantastic. It's extremely easy. Can anyone give us an idea on how to differentiate this? Can anyone get us started on this?
Would you do 2 times 3 times x over 2 minus 1? Or excuse me, to the exponent of 2 minus 1?
Sorry, can you say it again? Well, please.
Would you do, I'm blanking on the term, but 2 times 3 times x, and then you put the exponent 2 minus 1, n minus 1?
So you may be correct. I'm just not following, but you may be correct. So natural log of a function prime is 1 over the function times the inner function prime. If that's what you're saying, the answer is yes.
No, I was a little bit off, but
That's okay. That's okay. So all you need to do here is just condense it, write it as one single fraction. It's easier. So I apply the rule that we just looked at. 1 over the function times the function prime. And this is it. There is nothing else to it. Is this okay? Thank you for trying. Yes, yes.
The inner function prime, you're multiplying it to, how did you get the 6x plus 2 again?
When we differentiate a polynomial, we differentiate each term. When I differentiate this term, I bring down the 2, I multiply it by 3, and I subtract 1 from the power. When I differentiate 2x, I differentiate x, which is 1, so 1 times 2 is 2.
Okay.
Better? Good. You need to ask questions. It's always easier to solve these in class or next time after you review. I prefer as soon as possible. Good. Once you review the work that we did before class next time, you will have questions. But if you don't review it, you may not have questions, and that's not good. You know me, I love questions. So let's find this 23. Y equals x natural log of x squared minus 1. And they want us to find an equation of the line tangent to the graph of this at x equals 3. We had literally almost every function, every derivative, we determined equations of the tangent. So we know that the equation of the tangent is y minus y1 equals the slope times x minus x1. I only have this 3. How do I determine this, and how do I determine this? How do I determine y1?
Did you just plug 3 in? for
Thank
X
you.
in the original?
Thank you for saving us. Thank you. Thank you. So I go to y equals, I clear and clear, and I plug in the function, which is x, natural log, in parentheses, x squared minus 1. And second on table, and I plug in 3. Okay. Now, they may ask us to use the exact answer. I don't like this answer of 6.24. So approximately y1 is approximately 6.24. But they may ask us not to round up or down or whatever, which means when I plug in 3 here, I have y equals 3, natural log of 9 minus 1, which is 8. You may be required to keep y1 as 3 natural log 8, as this piece here. So y minus 3 natural log 8 equals the slope x minus 3. So this is the approximate, and this is the exact. This is the exact. Good. So let's keep it exact. Now, what do I need to do to find m? What did we always do? What were the steps towards finding m? We should not have to think about this. Please. How do we find m, please? Anybody? We've done this for many, many functions so far.
Is it y2 over y2 minus y1 over x2 minus x1?
So the slope is f prime of 3. Please understand that the derivative evaluated at 3 will give us the slope of the tangent line to the graph of that function at that point. What point? 3 comma this. So the point in discussion is 3 comma 3 natural log 8. So please remember one more time, the slope of the tangent line is given by the derivative evaluated at that point. So that's why I'm asking my students, begging my students to review what we do in class. It's the only way to make it stick. Okay? Please understand that. And if you go back to the notes, you will see that we've done this many, many times in the homework also. Good. So I have to differentiate this, and it's a product. I have to use the product rule. So y prime is, first function prime is 1 times the second function plus the first function times the second function prime. Can anyone try the second function prime? This prime, please.
Is it 2x?
1 over the function times the inner function prime. Okay, let's go back. Natural log of x squared minus 1 is 1 over x squared minus 1 times the inner function prime. Good. Is this clear? Yes, no? Good. So then I will continue writing it as natural log of x squared minus 1 plus 2x squared over x squared minus 1. Y prime evaluated at x equals 3. Y prime evaluated at x equals 3 will give us the slope, which is an ugly slope because it has natural log in it and I can't approximate it. So 9 minus 1 is 8. So I have again natural log 8 plus 2 times 9. 18. What do I have here? 9 minus 1, 8. So the slope is natural log 8 plus 9/4. Terrible, but this is what I have to use. So coming back to the equation, y minus y1, here's y1, 3 natural log 8 equals the slope, natural log 8 plus 9/4 times x minus 3. So let's think for a moment and see if you have any questions, anything. See if this is clear. If it's not, please say so, and I'll go back. Is this okay? Please say something. Anything? Anybody? Do I need to go back and explain anything?
Could you do one more problem?
Oh, we haven't finished.
Well, yeah.
Of course we will. So now, assuming they're asking me to, normally we have to solve for y. So I have to just write natural log 8 plus 9/4, and I will distribute it to x. But then I have to distribute this to -3 and also bring +3 natural log 8. So -3 times this is -3 natural log 8, nice. And this times this is -27/4. So this is final now. What is final? So let me explain again what I did. I distributed x to this group. Leave it alone. Then I distributed -3 to natural log 8 and -3 to positive 9/4. But also this was -3, that's natural log 8, and I had to bring it to the other side as positive. Luckily, those two disappeared. And now the final simplified form of this equation is y equals, leave it alone, don't change anything here, plus 9/4 x minus 27/4. So the difficulty here was not the algebra, not the differentiation or the algebra. The fact that we had to work with these numbers instead of really approximating, but the approximation is not good enough.